Welcome to The Explainer. Today, we're diving into an absolutely monumental shift that's happening right now in technology and, well, the global economy. For decades, the artificial intelligence we've interacted with was kind of trapped behind a screen, right? Generating text, analyzing data, maybe beating us at chess. But that's changing. The brain of AI has finally met the body of robotics. We've officially entered the era of physical AI.
Okay, let's dive into this. I want you to imagine a worker who literally never sleeps, never demands a raise, and costs less than your morning latte for every single hour of labor they perform. Now, for a long time, the idea of a humanoid robot actually filling that role was treated as straight-up science fiction, or, just a playground for laboratory acrobatics. But as we move through 2026, the punchline has officially become the production line. We're looking at a scalable workforce that is completely immune to the limitations of human biology.
$2.75. Seriously, think about that number, because this is the math that changes absolutely everything. When you take a humanoid robot, manufactured via mass supply chains in China, with a target price of around $16,000, and then you factor in a 3-year depreciation cycle, your standard maintenance, and power consumption, well, if you run that robot for 2 8-hour shifts a day, it effectively costs less than $2.75 per hour of labor. Even before reaching full upfront cost parity with humans, that hourly operational math, it makes this a reality we just can't ignore anymore.
So, how exactly did we get here so incredibly fast? Well, understanding the transition from the old era to the new one is absolutely crucial. In the old era, robots relied on these heavy, clunky hydraulic systems and super rigid pre-programmed scripts. Like, if a parts bin was moved just an inch to the left, the robot failed. Complete system halt. But the new era? It's entirely electric and fully autonomous. Today's robots aren't just blindly executing lines of code, they're making real-time decisions in totally chaotic, unpredictable factory environments. They can actually adjust their grip and stance on the fly.
A perfect example of this is the new Boston Dynamics Electric Atlas. They actually retired their famous hydraulic prototype to build this all-electric, production-ready workforce. The new Atlas features 56 degrees of freedom and these incredible custom actuators that allow for 360-degree rotation of its torso and limbs. It gives the robot this superhuman, frankly almost alien flexibility. Imagine it's in a super cramped factory cell, right? If Atlas needs to grab a part behind itself, it doesn't even need to turn its whole body around. It just rotates its torso and limbs backward. That drastically reduces cycle times.
And then, of course, we have Tesla's Optimus Gen 2. What's super fascinating here is how Tesla is leveraging its massive existing scale. Optimus is maturing from a walking prototype into an actual general labor commodity. See, Tesla essentially took the visual AI developed for its autonomous cars, the neural networks that understand roads, pedestrians, and obstacles, and just ported them directly into Optimus. The result is a robot that can seamlessly navigate massive gigafactories and use millimeter-level tactile precision to do things like sort delicate battery cells without crushing them.
Now, you might be wondering, what's the underlying secret sauce making all this possible? It's something called a large behavior model, or a vision language action model. Instead of just understanding pixels on a screen or predicting text tokens like ChatGPT, these breakthrough AI models actually understand the physics of the real world. This is a huge deal, because a floor supervisor doesn't need a master's degree in robotics to change a workflow anymore. You can literally just tell the robot, hey, prioritize the heavy components today, and it uses visual reasoning to identify the heavy parts and sort them. No new code required whatsoever.
And the secret to how these robots are getting so smart, so fast, brilliantly comes down to the continuous cycle of sim-to-real transfer. Robot foundation models, like NVIDIA's GROOT, don't learn by stumbling around a physical factory floor for 3 years breaking things. They learn inside physically accurate digital twins. Inside these simulations, the AI can train at 1,000 times real-world speed. It gets to encounter millions of weird edge cases, like weird lighting, dropped objects, shifting bins, long before it ever touches a real factory floor.
But as mind-blowing as the tech is, the real disruption here is the math. In a lot of developed economies, the median salary for production workers hovers around $45,000 a year, and that's before benefits. Meanwhile, advances in mass manufacturing are driving hardware costs right off a cliff. We're already seeing target robot prices hitting $16,000, and companies like Unitree are out there offering humanoid models for under $6,000. In a world dealing with acute labor shortages, this massive cost convergence makes humanoid adoption an absolute competitive necessity. And I really need to emphasize this point. This is not some theoretical concept for the 2030s. This is happening today. We're already seeing real-world commercial pilots in action. You've got UB-Tech's Walker S out there interacting naturally with retail customers. And Agility Robotics Digit, it's currently pulling 16-hour shifts, handling box logistics, and moving totes for major fulfillment centers. They're working right alongside human workers safely and efficiently right now.
All of this economic gravity is fueling a market that Morgan Stanley projects will reach a staggering $5 trillion annually by 2050. Just to put that into perspective for a second, that would make the humanoid robot market roughly twice the size of the entire global auto industry today. The financial incentives for companies to automate have literally never been higher.
All right, which brings us to the AI layoff trap.
Economists are actually sounding the alarm on a really sobering macroeconomic paradox. We are stepping right into a competitive prisoner's dilemma, which is often called the Red Queen effect. Because the cost savings of physical AI are just so massive, better AI forces companies into a race to replace workers just to survive. Think about it. If your competitor cuts their labor costs by 80% using robots, you have to do the exact same thing, or you're out of business. It just amplifies the pressure to automate faster and deeper across the whole economy.
So the crucial point is this. When an individual firm replaces a human employee with a robot that costs $2.75 an hour, that specific firm keeps the profit, right? They boost their margins. But collectively, on a macro scale, every single time that happens, the economy loses a human consumer with a paycheck. It ultimately erodes the very consumer demand that these individual companies rely on to buy their products in the first place.
And the potential human cost of this transition is staggering. We are looking at projections claiming that AI and robotics could replace up to 800 million jobs worldwide by 2030. That is the scale of labor disruption that modern society has literally never had to navigate in such a compressed time frame.
What this creates is what economists call profound job polarization. Those middle skill roles, the repetitive, structured jobs in logistics, manufacturing, and warehousing, they're being decimated. That leaves us with a totally hollowed out workforce, split into two extremes. On one end, high-skill AI experts and robotics engineers. On the other end, low-skill manual roles that require complex, unstructured human touch that's still too tricky for current sensors to replicate. Now sure, there's hope that the reinstatement effect will create 97 million new jobs we haven't even thought of yet, but right now, the speed of displacement is completely outpacing our ability to reskill the workforce. So to summarize what we've unpacked in today's explainer, we are standing at the very edge of the largest shift in industrial production since the assembly line. For years, AI was trapped inside our computers and robots were trapped in their rigid programming. But not anymore. The brain of AI and the body of robotics have finally caught up with one another. Physical AI is here and it is actively reshaping the very foundation of how things are made and moved. The labor market you knew yesterday, it's never coming back. Which leaves us with one massive looming question. How exactly do we structure an economy where human labor is no longer the primary engine of growth? If you want to stay ahead of the curve in this $5 trillion revolution, make sure to subscribe and hit that notification bell. Thanks so much for watching The Explainer, and we'll see you next time.